Okay, moving on to problem number 2, which is the same sort of problem as problem number 1 that I just did. And I'm going to do the exact same logic behind this problem as was behind problem 1. So it's essentially the same sort of steps, but just to recap, I need to find this area right here. And to do that, and it's between this and this. So between this x and this x. So to do that, I'm going to find what's the area right here. What's the area below the f function. And I'm going to subtract out this area right here, the area that's below the g function. And when I subtract that g area out, I will be left with the area that I'm looking for. Okay? So again, I'm going to find the area below the f function. I'm going to subtract out the area below the g function, and that'll give me my answer. These are simpler functions than problem 1, so it should be a little bit faster. So I'm going to start with my f. I'm going to find the area below the f function. To do that, I need the integral of this f function. I'm just going to use the power rule for integration. I add a 1 to my power, so that's going to be x to the 5th, and then I divide by that exponent, 5. And I'm going to evaluate it from 0 to 1. And to do that, just like problem 1, I first put my upper limit into the function. So it's going to be 1 to the 5th divided by 5. Then it's going to be subtract. And I put my 0, the lower limit, into the function. So it's going to be subtract 0 to the 5 divided by 5. That is much easier to calculate than problem 1. 1 to the 5th, that's just 1 times 1 times 1 times 1 times 1. Well, that's 1. So 1 to the 5th divided by 5 is just 1/5. So that's going to be 1/5. And this right here, 0 to the 5th is just 0 times 0 times 0 times 0 times 0 times 0. Well, it's just 0. So that's 0 divided by 5. And 0 divided by 5 is just 0. So this is minus 0. But if I subtract the 0, I don't have to put anything. I just put 1/5. So that is this area right here. That's the area underneath your f function. It's 1/5. I'll go ahead and put that off to the side to remind me that's what it is. Then I'm going to find the area below the g function, this stuff right here. To do that, I got to find the integral of this. Okay, so I'm going to erase all this stuff. And I'm going to find the integral of the g function. Well, I use the power property for integration. I add a 1, which is going to be x to the 6th. And then I divide by that exponent, 6. I'm going to evaluate it from 0 to 1. And I'm going to put a 1 into my function just like I was doing on the last one. It's going to be 1 to the 6th divided by 6 minus... Now I'm going to put that lower limit in, 0 to the 6th divided by 6. And when I do that, 1 to the 6th just 1. So this right here is just 1. So it's going to be 1 divided by 6 minus, and 0 to the 6th is just 0. So this is 0 divided by 6, which is just 0. So it's going to be 1/6 minus 0, which is just 1/6. Okay? And to get my answer, I'm going to take 1/5, which was this area, under the f function. I'm going to subtract out 1/6, which is the area under the g function. And we'll see what we get when we do that. Okay, and when you do that, you're going to get 1/30. So the setup is area under the f function, subtract the area under the g function, and when you subtract those, you get 1/30. And that's your answer, 1/30. as a fraction. If they want it as a decimal, you just put that in your calculator, and you see what that decimal is. But yeah, that's your answer right there. So yeah, that one was a lot quicker. But I'm gonna end the video here. It's a short one. It should be pretty easy to upload, and then I will continue with the videos here in a minute.